So today I'd like to talk about humanoids, and most importantly, since of course we're at a BMS seminar, how do we power, right, those humanoids? So I will start, with the introduction about this market that, as most of you know, is booming. You see every day a new humanoid company, releasing a new robot or, planning to go to mass production. But you know what? One of the main challenge or clear challenge today that most of these companies that are investing in this market face is how long the battery lasts, right? A lot of these humanoids out there, maybe the battery lasts 1 hour, and that's is not efficient for those customers or for the end application ROI, right? You want that the battery lasts hours, right? You want that your robots operate as long as possible and make sure you avoid any downtime while your robot is operating. So before going into humanoids, I will just walk through the history of robots and where batteries are present in those robots, and how we can all work together again to make those battery as efficient as possible. And the history of robots started 60 years ago, right? 60, 70 years ago with industrial robot. Of course, those maybe have some battery backup, but they run out of AC mains mostly, right? They're usually encaged, or they have like some safety bubbles around it. And then as we in the last years, we see more and more of collaborative robots. As you know, we want those robots to cooperate. We want those robots to collaborate with humans, right? And you see those now collaborative robots moving from static actually to mobile platform. Let's say in a wafer fab, right? You will find those mobile platform with the arm on top that will move wafer lots from a place to another, right? And guess what, again, those mobile robots, mobile platform, they run on batteries, right? Usually it's 48 volts type of batteries. And again, you need to maximize the runtime of those batteries to make sure the ROI, right? What you're investing, eventually you get it back, right? And then, of course, home service robots, these are the ones we find in our houses. Those also are battery powered. And then finally, as I said, right, humanoids, where we see, and the reason why humanoid is becoming more popular, and it's for two main things. First of all, the flexibility, right? When you have a mobile robot, right, if you have, let's say, a step in your factory floor, or let's say you have stairs, right, your mobile robots can go down the stairs or cannot go on top of the step that is in front of him. Humanoids, basically solve that challenges, right? So for even a brownfield, right, it's very, very easy. I don't want to say easy, but it's easier, right, to install a robot that is there, especially, with the advancement we're making in the AI world. Those robots really allows you to perform different type of function, even complex, in any environment. And so, few things before I, dive deep into the BMS problems. But these are some of the areas, that TI actually is investing in terms of technologies and in terms of products for humanoids. Going from the motor control, which is actually the part of the robot that makes it move, and that the BMS is powering. And then you have the computing platform. This is the brain of the robot. So those are the GPUs, right, that we are talking about every day, right, in the news. Sensing, it's a big piece of it. Sensing, of course, current sensing, temperature sensing, and then, perception sensing, like, for example, to make sure the humanoid is able to move around the environment that is working, or where it's cooperating or collaborating with humans. Communication. So most of the humanoids today are run on CAN interface, moving to EtherCAT. And then we see also a trend to move single pair Ethernet. As you know, you can run power over the cables, and you can basically reduce the entire cable, so making the robots lighter, right, at the end of the day, and the whole network piece, more or less complex. And power, right? That's, I think, why you're all here today, right? How do you power those humanoids, right? How do you make sure you create a system that have high energy intensity, very efficient, again, that run as long as possible. And the underlying technology that actually is common to all these subsystems is functional safety and artificial intelligence, right? And I want to emphasize the functional safety piece because it's very important, as those robots will cooperate and collaborate with us, and eventually we'll have also them at home. It's very important that those robots are safe, right? That the designers design them in a way that every time that they fails, you can predict that failures, so that the robot is not going to fall unpredictably and cause maybe some damage. So you want to control that, right? That failures, and make sure you implement those safety features. And the safety piece, actually, I was in Seattle just a few weeks ago at the Humanoid conference. Actually, they just started a working group in Boston. They defined the safety standard. I think it's ISO 25785, if I remember right. And it's going to be actually released in 2028. And of course, as you know, the safety committee want to learn, right? And from the use cases where those humanoids will be deployed and build the safety standards on that, right? And the reason why I'm emphasizing so much safety is because, of course, for BMS is a key piece of that functional safety piece, and that should be the foundation of every of those designs. And yeah, just want to highlight quickly, not spend much time on this slide, but really the opportunity, right, that is here for humanoids. Today you see mainly prototypes, right? Customer building prototype, and then use those prototypes for basically training those humanoids prototypes. So you will deploy them in factories or wherever in the lab, and the robot will train, right? Will train until we see in 2027, which is going to be basically the inflection point where a lot of these prototypes will go to mass production. And that's actually the reason I'm also bringing this up, because we are in a very important moment, inflection point, because a lot of these prototypes have not been optimized when it comes to power. As I said, a lot of the OEMs I talk with, the battery runs maybe, I've heard even 1 hour. I don't know if you watch the Olympics, humanoid Olympics in China, a lot of those robots run out of power in no matter of time. So as we walk through 2027, the BMS piece becomes so important, right, for those humanoids. And we need to make sure all of us, right, work to make that piece more efficient. And here, just, a highlight, overview of what are the different pieces of the humanoids. You will see, 60% of the electronics actually is motor control, motor drive, but then you have of course, the sensing piece, and then you have the battery pack piece, right? And all of these pieces are important, and they work together in order that, the robot is fully functional. When it comes to now let's go a bit deeper, right, into the BMS piece. When I think about the BMS piece, I think it like the nervous system of the robot, right? So it's important, and the reason it's important is because you want to make sure, right, that actually your robot is always functioning, right, and have that power source, continuously fueling, right, the robot's actions and or the robot's execution of task, right? And the reason why this is important, right? You want to monitor, the current, you want to monitor the temperature in order to optimize at the end of the day, the energy density, right, of your system, as you want to have the highest as possible. Because, of course, one piece is you want to have that battery packs as small as possible, because you want, that they are not weight, or they don't weigh so much, right, to, you don't want your robot, first of all, to weigh a lot, and because that will impact eventually also the runtime. And then it's also important you avoid any, thermal runaway, and you make sure that every time, that the robots is running out of power, you predict that so that it can go back to the docking station, and charge itself, right? You don't want that the robots, run out of power unpredictably, and fall on something. So things like, state of charge, things like state of health, right, are so important to, do things like, have a smart way to predict or to forecast, the path of the robots when it goes, let's say, to the charging station. Again, at the end of the day, to optimize or to increase the ROI, right, how long the robot is going to run. So, and the BMS, right, has a key role here in the humanoids space because of all what I just said. So it's super critical, having accurate, cell monitoring and balancing. You will have, multi-cells, so you need to make sure, those cells, again, the balance, their balance. It's very important, as I say, fault, that, you detect all these faults and, you run continuous diagnostic. And then, as I mentioned again, right, you will hear me talking a lot about the functional safety piece, right? It's important that the BMS, right, is compliant to those functional safety requirements. Again, in order to make sure that, you basically fail safe, right? So every time that there will be a failure, right, you are able to take action and, make sure that the robot fails safe. So few of the, when I talk with OEMs and, around the world, and, I talk specifically for this subsystem, I talk about the BMS. Few of, the design requirements that, they always come out from our discussions when I talk to them is, first of all, robust protection for, the voltage, the temperature, and the current. Then, as I said, those measurements of, the currents, the voltage needs to be very accurate, down, to the individual cells. And as I said, it's super important also to have a very accurate state of charge and state of health, right? Because you can maximize, at the end of the day, your battery performance, and you, at the end of the day, can maximize the runtime, right? And things like, why it's important, right, to measure accurately, like the current, right? Because, I guess all of you may be, familiar with drones or EV, electric vehicles, right? And those type of equipment or power tools, I think it was mentioned before, those type of battery-powered equipments are pretty static, right? The car, I will drive on the road, so it's pretty static, right? The drones is kind of static, maybe less of the car. The humanoids, it's not, right? Again, imagine us, right? We move continuously, we lean down, we move around, and the same for the humanoids. So it's a very dynamic. So the changes, in the currents and the likelihood you will have those spikes is higher than any other equipment. And then also, what we see is also like regenerative braking, right? So basically, sending back the energy you don't use back to the DC bus, right, of the robots. So you want to make sure that it doesn't overload, right? So having, these current measurements back and forth, it's super important, and it's very important that those are accurate for the exact reason I mentioned, right? That the humanoid, compared to other systems, is very, very dynamic. So before I jump into the system, right, and how that looks like for a humanoid, just want to spend a few words about functional safety and why is that important. Of course, as the work close to us is super important. A few things, to keep in mind, and what, some of the failures can lead to is like, as I mentioned, you don't want, sudden shutdowns, right? You don't want thermal runaway. You don't want the robot lose mobility or control. And, having devices and systems that are compliant to those functional safety standards, it's super important to basically make sure you prevent all of this and predictably mitigate all those faults. When we look at the humanoid battery management system, so you will have, of course, it's a 48-volt, right? Maybe I didn't say that enough, but yeah, it's a 48-volt battery, right? So you will have on the left side, you will have here the series of cells, right? And you want to measure, the temperature of those cells. Then you will have battery monitor protector, right? That, sense the voltage, sense the current, the temperature, right? Does all the things I've said previously in order to make sure, is actually monitoring and protecting our battery pack. As I said, having a gauge is actually, we see as a good addition there, as you want to accurately monitor again the state of charge, the state of health, for the exact reason I mentioned previously. And then, of course, you will have an MCU that, will take care of all, the monitoring, and finally the communication. So right there, I put the three basically type of communication that we see today, as I said, mainly CAN, moving to EtherCAT, Ethernet-based systems, and then moving in the future to single-pair Ethernet. And then, with my team, we basically look at, what is TI devices, that we can basically position in each of these functions. And you will see some of them, right? And of course, these are not all of them. We just pick, the ones that we believe are the best fit for solving those specific challenges. And you will see, right, and here the breadth of TI portfolio, right, that they can address an entire BMS system just and only with TI devices, right? And I will go with, especially on some of them related to BMS, like, for example, this BQ76972. This is a 3 to 16 cell accurate battery monitor system with the high-side FET drivers that, actually enhance the safety or allows, the system to meet some of the functional safety requirement. I think what I like about this device is the highly integration. One thing actually I've not mentioned today as a challenge or as a requirements that I hear from those OEMs that build humanoids is integration. I mean, again, those humanoids are the size, similar size of us, right? That you need to put now all the electronics in such a small size, right? So the integration that is needed, right, to make sure, you don't build a giant, but you build like a humanoid that actually can be used, is very important, right? So integration of the semiconductors of the electronics, beyond, of course, the mechanical piece, is super important, right? So one thing I like, for example, about this device is, the integration, right? You can integrate a lot of things, right, into it, like protection, monitoring, and so on, right? And then the capability to maximize the cell capacity with again, the high voltage measurement is critical, right? Again, to have those cells that last as long as possible. And then, actually, what my team does is we look at the customer challenges, understand those customer challenges, in this case humanoids, and then we look at TI portfolio, and then we build system solution, right? And that's how we help customers, that's how we can help you, right, to develop those BMS system, and even beyond BMS, right, motor control, perception systems, to be used in your application, right? So here is an example, actually, of what our team has built, right, using those parts. So we build a high accurate battery management systems. This actually can go, here we're talking about humanoids, but this also could be used in, for example, in solar system, right? ESS. So, and you see, right, we can stack cells, right? Could go from 48 volt down to 1500 volt. Here using the same devices. I'm not sure if you can see the block diagram there, but using the same devices stacked one after the other that I show earlier, and you see, right, again, same points, right, and I will continue to emphasize them, and that we also capture here in the reference design, the accurate voltage, accurate sensing, accurate current sensing, right, is one of the key features of these parts, but of the entire reference design, right? One thing also you could do is integrate everything together, right? Integrate even more, right? As I said, integration is a key piece, right, to make those robots smaller and the system smaller. So here actually is the same block diagram I showed before, but let's integrate now the monitor, the protector, and the gauge into one device. And we actually have that device, right? The BQ41Z90. So I think we just released that a few months ago. So, and this device, as I said, can do accurate state of charge, state of health. Again, that's very important that you know exactly what is, or as accurate as possible, what is the charge of your robots, where you stand at, because then the robot can, predict in a very accurate way when it's gonna run out of gas, right? And as it's gonna run out of gas, okay, where is my charging station, right? My charging station is maybe on the other side of the factory, right? And do those calculations to make sure, okay, I have, to go on the other side of the factory, I have maybe 10 minutes. And I have this amount of charge, right? So how long it will take me based on that amount of charge, and based, also on the movement I'm gonna do. And that's basically when AI come into the game. So those AI systems will learn, right, actually as the robot perform task, and they will learn, okay, as I'm working now on this task, and as I need to go on the charging station, and while I do that, I will use some power, right, of course, because, your actuators are up and running, right? Okay, it will take me that amount of time. And so basically, you can, at the end of the day, maximize the operation time of the motor. That's why things like these gauge devices are so important, right? And we see more and more of interest, right, in the industry, especially when, you can combine different functions, like monitoring, for example. And then, of course, protecting the system from, using other battery packs. This is one of the features that this device have. You want to make sure you use the right battery pack. And then, again, you must be tired of hearing me saying that, but the safety, right, is so, again, important. Detecting those over voltages, under voltages, over current, undercurrent, over temperature is critical, and this device, solve or mitigate a lot of this risk. I talked enough about this device. How actually we achieve this, accurate state of charge. I'm not the expert here, but I'm sure we have a lot of the people from the businesses that can tell you more about this. But we have this newly patented dynamic Z track, right, that allows, to do that. And then, I already mentioned about the capability of this device and what it can give. In the last minutes, I would like to quickly go through the charging methods for those robots. Usually, we see like 4 types of charging today. The tethering, of course, here you will have to plug the cables direct into the robots. It's simple, but it limits the mobility of the robot. So we see maybe this in where the robots is, for example, in the hospitality industry or in retail, right, where maybe it doesn't need to move a lot, but it can still perform tasks or can interact with the customers. Docking, this is the one we see today. As most of the customers actually are doing that, docking. So basically similar to the vacuum robot you have at your place, right? The robots just go, or the lawnmower, it just go into the docking and charge itself. But here, you might have, or you need to consider about alignments to the docking station. Swapping, of course, here, the picture, it looks like the robot swap put the battery on the charger, but of course, he has other batteries, right, in the body, because if not, it could not work. So this actually, we see already some customers doing that, right? Ubitech, I don't know if you've seen, they just announced the Walker S2. Ubitech is a customer in China, and actually they have, I think 4 or 5 cells, and what they do is, basically, the robot is able to remove the battery and put it, to charge, and take back another cell, put it back, and so get back to work, right? And that's, I think, we see this also as a pretty good solution again to optimize the runtime of the robot. And then one of the solutions that I think today is, at least at these power levels, I don't see a very good solution. But I think from a practical point of view is one that will work the best is wireless charging, right? Because that really allows you, or allows the robot actually to charge itself, at the best time, when it's convenient, right? And do this on the fly. And a few things here also, we work on. I will go very quickly in the next slides, but just for everybody to know. But we have also a pretty strong portfolio when it comes to a CDC charging. Again, the name of the game here is efficiency. We try to build a high efficient, in this case 3.6 kilowatt AC to DC, using actually our GaN technology. I didn't talk about it today, but GaN, when we talk about efficiency, is super important. Either it will be in the motor control of the robot, and we have actually GaN FETs, single driver, half bridge drivers that can be used either in your AC/DC converter or, for example, in your actuators, right? And then we have different flavors, right? I talk about 3.6 kilowatt, 1 kilowatt AC/DC. Again, here our focus is really efficiency. How do you make the conversion as efficient as possible? And those will actually connect, and this is my last topic, will connect to your backboost controller. You saw those, they had the output 54 volt, 48 volt, right? So it depends. And that AC/DC stage will connect to this backboost controller that will charge your battery, right? And here, it's again an example of this device, this 80 volt input voltage, max input voltage backboost controller that can charge different type of battery, like lithium ion is the most used here. It has adjustable switching frequency that again can optimize the efficiency, right? EMI and size of the entire system. Again, a lot of integration here for the exact same reason I've mentioned. This will be on the humanoid, while the AC/DC will be external most of the time, this will be on the humanoid size, very close to the battery that is going to charge, right? And a few of the features of this device, I talk about 80 volt, which is input voltage, which is a requirement that most of these customers ask. We have heard also up to 100. Multi-chemistry, the power stage is pretty flexible. Again, different type of interfaces, internal ADC to measure, the current of the battery, the voltage of the bus, whatever, right, is needed again to achieve those safety requirements. And this actually was the last piece, and then that I want to talk about. And then, of course, you will find this was just a snapshot, right? I tried to focus on BMS and giving you an overview where BMS fit in those robots and why I see those robots as a growing market. But you will find much more, right? We have actually these engineering guides where we talk about the actuators piece, we talk about the sensing piece, we talk about communication, which is very important. So feel free to look at it. Thank you.